Okay, AP Chemistry students, in this video we're going to see how to mathematically represent the law of definite proportions based on the mass, because that's what the law is based on. It's the mass that each atom contributes to the overall formula. Now, if you take a look here at NO2, you will recall from the previous reading section that NO2 is 1 nitrogen for every 2 oxygens. That literally translates as only 1 mole, let me make this look like a 1 mole of nitrogen for every 2 moles of oxygen. Well, what is the mass that each of these contributes to? What are the gram amounts? And it turns out that you can figure that out by doing a simple mole conversion like we learned in topic 1.1. So overall, nitrogen contributes 1 mole of nitrogen to the nitrogen dioxide formula. Well, how many grams is in 1 mole of nitrogen? Well, we're going to need to multiply by a fraction, okay? This is our mole conversion. Guess what you need to convert grams to moles? Drum roll, please. What is it called? The molar mass. So you need to go to your periodic table that you picked up and look for the molar mass of nitrogen, and it just so happens to be that it is 14.01 grams to every 1 mole, okay? Remember, mole needs to be on bottom here because we got to cross cancel that, which means gram needs to be on top. Gram with mole, mole always gets the number 1, and then the molar mass always goes with the grams, okay? These cross cancel. Actually, take that back. The n stays, but the moles go away. And then now it's handy dandy trusty calculator time. 1 times 14.01 means that overall nitrogen contributes 14.01 grams, okay, to this whole formula right here. Well, how many does oxygen contribute? We have 2 moles of oxygen, okay? We need to multiply that by the molar mass of oxygen, okay? Moles down here, grams up here. Take a look at your periodic table. What is the molar mass of oxygen? It's 16.00. Gram with mole, mole always gets the number 1. The moles cancel. And then you have 16 times 2, which is 32.00 grams contributed by nitrogen. All right. One way you can check yourself to make sure that you did this right is to add these up, and add these 2 numbers up right here, that is, and if that is equal to the entire molar mass of NO2, then you've done it correctly, and you know how to calculate the molar mass already. Let's do another example. Here's hydrochloric acid, and we know that for every 1 mole of hydrogen, there is 1 mole of chlorine, based on this formula right here. So how do we figure out how many grams, or what's the mass that each element contributes? Well, we have 1 mole of hydrogen. How many moles, or how many grams is that? We got to multiply by the molar mass, okay? Grams on top, moles on bottom, so that the moles can cancel. Take a look at your periodic table. The molar mass of hydrogen is 1.01 to every 1 mole. The moles cancel, and you have 1 times 1.01, which is 1.01 grams are contributed by hydrogen. Now let's take a look at chlorine, okay? In the formula there is 1 mole of chlorine. Well, how many grams, or what's the total mass of this thing due to chlorine? We'll take a look at your periodic table. The molar mass of chlorine is 35.45. The moles cancel. What's 1 times 35.45? That's 35.45. Grams are contributed by chlorine, okay? And once again, the way to check yourself is to calculate the molar mass of chlorine, and then add up these 2 numbers here and see if they match, or if they're very close. If they match or very close, then you probably did this correct. Alright, let's look at our final example. Here we have 2 moles of potassium for every 1 mole of sulfur. Well, what's the mass that each element contributes to the total thing? Well, let's take a look. We got 2 moles of potassium, that's K. How many grams is that? You need the molar mass of potassium. On the periodic table, it's 39.10 to every 1 mole. Those moles go away. Then you're going to have 2 times 39.10, which is going to be 78.20 grams. I did that in my head. Let me verify with a calculator, because I'm always making mistakes with arithmetic. Times 2, 78.20. Perfect. We're good there. Is contributed by potassium. Okay, same thing with sulfur. We have 1 mole of sulfur. We need the molar mass of sulfur to figure out how many grams that's going to be. Okay, there are 32.0 grams to every 1 mole of sulfur. That's its molar mass. Those moles go bye-bye. 1 times 32.0 is 32.0 grams are contributed by sulfur. Okay, and again, the way to check yourself to see if you're correct: calculate the molar mass of potassium sulfide, get that number, and then check to see if it's the same as when you add those 2 numbers together right there. Alright, ladies and gents, that's all there is to modeling the law of definite proportions mathematically. We could even take this a step further, and instead of asking you for the grams, we could ask you for the particles, in which case you have to use 6.022 times 10 to the 23rd. So just be prepared for that as well in a future example. Okay, ladies and gents, the next slides will be a little quick check quiz for you, and then we will see you back here for the next topic.